So today's lesson, we're going to start talking about simplifying rational expressions. And I think that this is kind of a fun lesson. This is one of my favorite algebra topics. I actually enjoy doing this. First, we'll define a rational expression. A rational expression is a fraction in which the numerator and or denominator is a polynomial. So if you don't like fractions, you might not like this, but try not to approach it from a negative spin from the beginning. So here are some examples down here. These are all considered to be rational expressions because they are fractions. A rational number is defined as a number that can be expressed as one integer over another as a fraction. So this would represent integers. And an expression has no equal sign. An expression is just like what we've been working with. We've been factoring expressions, multiplying expressions, but we've not been solving them. We've not been trying to figure out what the variables represent. You will be able to do that sometimes. In Algebra 2, you'll do a little more of that, but we've just been working with the expressions. Okay, now all of my fraction bars are missing like they usually are. To simplify rational expressions, what we do is we factor the top, the numerator, and the denominator separately, and then we cancel out common factors. So if we look at the top of this example, we can factor this using our little tic-tac, which I'll just kind of write up here on the side. -8, -2. What two factors can I multiply to give me -8, add to give me -2? Gretchen?
-4 positive.
Good. -4, +2. So the two factors up here are x minus 4 and x plus 2. What about this bottom? Let's see, I'll do this one over here. 20. Wait a second. Yeah. I was thinking that one for a second. Okay, two numbers that multiply to give me 20, add to give me -9. Sophia? What's that?
1, 5.
Not just 4 and 5. We want the -9. Yeah, -4 and -5. So down here my factors are x minus 4 and x minus 5. So now what I can do to simplify that is the top and the bottom both have a common factor of x minus 4, right? This is similar. Say we had, let me write over here, say I had 4x over 4y. I could just cross off the 4's because 4 divided by 4 is 1, right? And I'd be left with x over y. I'm going to do the same thing here. If one of my factors is x minus 4 here and another one is x minus 4 here, that's like x minus 4 divided by x minus 4, which is 1. So that's gone. So my answer to this, simplified, is just x plus 2 over x minus 5. Questions? Okay, let's look at another example. Number 2, we have two binomials as the numerator and denominator. What could I factor the top binomial into? Is it a difference of squares? Okay, what could I factor it into? Is anybody awake? Rosa?
Is it x minus 5 and x plus 5?
Yes, x minus 5 and x plus 5. What about the bottom? Is the bottom difference of squares? Now, it doesn't appear to be anyhow because you have a 5x and you can't take the square root of that. Is there any common factor that we could factor out? Someone said it x. Okay, so when we factor out x, we get 5 minus x. Is there anything we can cross out? Are there any common factors on the top and bottom? Gretchen?
X minus 5 would that be considered to swap around?
They're almost the same, but they are swapped around. Is there anything we could do to make the 5 minus x turn into x minus 5? Athena?
Over 1.
Over
No,
1?
I meant under 1.
Under 1?
That would make it positive.
Not exactly.
Yeah, but if it was positive, then they would both be positive. and the other one is they're both positive.
So we want, if we look at this one though, this is the one where this one has a positive and a negative, so does this, but they're switched around. Is there any way we could switch those negative signs? Go ahead.
But I'm talking about the other one.
This
You
one.
cancel out that one if you put the bottom equation under one.
Under one, but I can't just put it under one because that would change. If I put it under one, are you saying if I did 1 over x times 5 minus x like that?
Yeah.
I can't just do that because that would change the fraction. If I actually did that, it would actually mean if I had x squared minus 25 divided by this fraction, 1 over x 5 minus x, it would move this x over 5 minus x to the top. It still wouldn't allow us to cancel it out because it's not the same terms. But what I need in order for it to be the same is I need these to be opposite signs. Gretchen?
I'm going to say multiply by -1.
Excellent. We multiply by -1. Now we can't just randomly multiply by -1 unless we multiply the top by -1. But what we can do is we could factor out a -1 from here. So instead of factoring out a positive x, if we change this to a negative x, this would be -5 and positive x. We'd have the same result. And we could rewrite this as -x times x minus 5. This is exactly the same as this. So we'll cross that one off. Now we have two common factors that we can cancel, x minus 5, x minus 5. So this one ends up being x plus 5 over negative x.
I kind of like this.
I really enjoy doing these. I think they're fun. It's kind of like solving a puzzle sometimes. Later on, my daughter's in Algebra 2, and she right now is adding these kinds of things together. You have to get a common denominator using polynomials. That's interesting. And then you have to change your top. You have to simplify them. You have to do all kinds of crazy things. Okay, so number 3. First of all, what can we do to factor the top? Gretchen?
Could you do 1 and 2, like make a tic-tac, 1 and 2, it would be 1 times 1?
Well, we can't use the tic-tac at all. Why can't we use the tic-tac yet? Sophia? It's not what?
You're not going to really use it.
Hannah?
You could add x to the 7 x to the 7.
Well, now I can't add them because they're not like terms. Liz?
Factor out x to the 5th.
Good. I could factor out x to the 5th. So I can't use the tic-tac yet because it has to be x squared to use the tic-tac. So if I factor out x to the 5th, I'm going to get x squared, which is what I want, plus 2x plus, what will I get here? 1. Good. You guys have learned that now. Okay, now I could use the tic-tac for the trinomial that's left. So I have 1 and 2. What are two numbers? That multiply to give us 1 and add to give us 2, Maddie. 1 and 1. So this becomes x to the 5th times x plus 1. I'm going to go ahead and write out my other factor. I could do x plus 1 squared, but since I'm going to be crossing off, it's kind of nice to have them actually written out. So I can ignore all this stuff in the middle for a while and just look at the top. Okay, now I need to factor the bottom. The bottom's actually already factored for me. The bottom kind of has an interesting thing here. We have an x to the 3rd as one of our factors, and then we have 8 factors of x plus 1. X plus 1 to the 8th means I could write x plus 1 out 8 times, which I'm not going to do because it would stretch across the whole board and I'd probably still run out of space. Gretchen? You have an idea?
I don't think this would work. Could we like backtrack, like multiply and make it another like full equation again instead of, because they factored it down.
No, we actually want to keep what we have there. We're on the right track so far. Emma, what do you think?
Would you jump the time with x? I think that's kind of what that's saying. X to the 3rd, x to the 3rd times x, and x to the 3rd times 1, and then do 8 times 1 and 8 times 1.
Well, you couldn't just multiply the x to the third times each of these terms because you have to do your exponent first. So you would actually have to multiply x plus 1 out 8 times before you can multiply it all by x to the third. I don't think you want to do that.
Then you just do x plus 1 to 8 first, and then you do x to the third time.
Are there any, just looking at it the way it is, let's go at this from a different approach. Are there any factors in common there? The x, okay. So what about the x? What if we just handle this x? We've got 5 of them here, x 5 times multiplied, x to the 5th is x times x times x times x times x. Down here we have x times x times x. So what would I be left with? If I just had x to the 5th over x to the 3rd, what would that simplify to? X squared. Okay, so on top, we know we have at least an x squared. So we can say we got rid of that now. Now, look at what's left. We have 2x plus 1s and 8
Oh, wait,
x
wait.
plus 1s.
Then it would just be x plus 1 versus power.
Yes. Okay, so if we have 2x plus 1s up here, and we have 8 of them up here, we can cross off these 2 with 2 of these. Say we had 8 of these all written out, we could cross off 2 of them, we would have 6 left. So this one becomes x plus 1 to the 6th.
You said these are fun.
They are fun. I'm sorry, I started you with some tricky examples.
The number 1 was actually fun, but these last two.
All right, go back now to the worksheet that I gave you. I'm going to continue recording on the worksheet. What I want to do is go over a bunch of examples with you so that we do a lot together so that you guys are pretty, and they're easier on the worksheet, so that you're confident with this and we can, you can do them on your own. Okay, so going on to the second page of your notes, you have a series of worksheets embedded in your notes. So we're going to do these together. We have 8x plus 56 over x squared plus 10x plus 21. Okay, let's see. Adam, can you factor the top for us? What's that? If we just factor just this, the numerator, are there any common factors between 8x and 56? 8. Okay, so we could take out an 8. What would be left?
7.
What would be left here? X. Good. X plus 7. So sometimes that's all you can do is pull out a common factor. Gretchen, factor the bottom for us, please. Okay. Good. So we'd have x plus 3 and x plus 7. Are there any common factors that we can cancel out, Zane?
X plus 7.
Good. X plus 7, x plus 7. So we're left with an 8 on top. And we're left with x plus 3 on the bottom. Are they back to being a little more fun now? These ones are a little easier. I wanted to show you some tricky examples, but most of the ones on your worksheet will not be that challenging. Okay, let's take a look at number 2. We have 60 minus 10a over a squared minus 11a plus 30. Okay, the top. Rosa, what could we factor out of the top? Well, we can't use a tic-tac for the top. We don't have a trinomial with a squared, so are there any common factors we can take out? 10. Okay, if we take out 10, what do we have left? Uh-huh. Now, we have a negative a there. We'll go ahead and leave that for now, but that's probably going to be a problem. We're probably going to want to do what we did with the other one and take out the negative 1. But let's move to the bottom and see if we need to do anything further with that. Jocelyn, what would we do to factor the bottom? Good. So we have a minus 6, a minus 5. Colin, do we have any factors in common?
A minus 6. Right now.
Almost though, right? So what can we do to that top one to make it like this one? We did it on the second example on the notes. Rosa?
Factor out -1.
Good, we can factor out a -1. So if we make this a -10, we can make this -6, positive A. Now they share that factor and we can get rid of it. So this one ends up being -10 over A minus 5. I'll wait till everyone gets this and then I'll erase the board and put up number 3. Is everyone good with these two? Okay, number 3. We have k squared plus 13k plus 22 over k squared plus 17k plus 66. Okay, for the top, Olivia, what could we factor that into? You don't have to do the tic-tac unless you want me to do it because you need to look at it.
K, plus 2, K and K plus 11.
Good. Okay, how about the bottom, Sophia?
K plus 6 and K plus 6.
Good.
And 11 cancel.
Athena, what can we cancel?
K plus 11.
So what do we have left as our answer?
K plus 2 over K plus 6.
Okay, good, well done. Let's do number 4. (6m) squared minus 2m over 18m minus 6. Ms. Bailey, what can we factor out of this one? 2m? Hello.
Hi.
Go ahead and try the next couple. Okay. Oh, yeah, that's why. Right. Okay, back to you, Bailey. You had time to think about this. 2m, good. So if we take out 2m, we're left with what?
3m minus 1.
Good. 3m minus 1. Okay, how about the bottom? Emma Lillybridge.
Back down to 6 and do 6 minus 3m minus 1.
Okay. Now, Gabby, what can we cancel out? Yep, 3m minus 1. What will we be left with? What's that? Not just 2 over 6, 2m over 6. Now, on this example, we are not finished. What can we do to 2m over 6, Lacey?
I was going to say you can reduce it,
We can reduce it.
but you can take down the negative sign and then
There's no negative sign. This is the 6 that we pulled out, so it's still positive. But yes, what would it reduce to, Lacey? Good, 1/3, or just, we still need the m though. So it would be 1m over 3, which would just be m.
Could you do that on
Over
the
3.
top one, like, make that this one?
No, that was a really good question. I'm glad you asked that. She asked if we could do this on the top one, because 2 and 6 look like they could reduce. However, this is one whole factor, k plus 2. And this is one whole factor, k plus 6. It has to be separate in order for us to do it. This is 2 times m. 2 is like a separate factor, because it's 2 times m. So we can reduce factors, we can't reduce things that are added on. So that was a really good question because that's a very, very common mistake that people make.
Would you be able to take out the K for the top four numbers?
No, you also cannot take out the K because again, these are attached by multiplication. You have to imagine them in parentheses, and unless they were the exact same thing, you can't do it. Okay, let's look at number 5. You guys can work ahead if you're, but you know, there's a lot of little extra things. I can't cover every case without going through a lot of examples. But feel free to work ahead through these. This one's actually a pretty easy one. Okay. Liz, can you do the top? So you're not seeing anything you could factor out? I don't either. There's nothing you can factor out. Is that a difference in squares? Can you take the square root of 36p squared?
Yeah.
What would it be? 6p. Can you take the square root of 49? 7. So it's difference of squares. So what would the two factors be? Not squared. You have to have different signs in the difference of squares. So difference of squares, you want 6p minus 7 and 6p plus 7. Okay, what about the bottom? Sam, what could I do there? Good. Okay, what am I left with?
16 minus
Okay, so Zoe, what would my final answer be on this one? Is there anything I can cancel out? Which one? The negative 7, okay. So what's left?
7 over 5.
No, we still have, you can't cancel out that 6p. You can only cancel out the whole term. So we have to look at what's in parentheses as a whole unit. You can't just pick one term or the other to cancel out. The whole thing has to cancel out with the whole thing in the denominator. So we'd be left with all of 6p plus 7 over 5. Okay. I think we're going to skip number 6 because I think number 6 and also number 7 should be fairly easy. Let's just do number 8. It's not that much more challenging either, but not to say that they're not all challenging, but it's not. It doesn't have any new ideas in it. Okay, so 8 we have 5r plus 20 and r plus 2. Kind of looks like the top might be factored already. Is there anything we can factor further on the top, Sophia? Uh-huh. Look at each factor separately. Obviously r plus 2 we can't do anything else with. What about 5r plus 20? Could we factor something out of there? Lacey? 5, yeah. So we could factor this a little further. We could factor out a 5, and then we'd have r plus 4 and r plus 2. Sophia, do you want to do the bottom, since that's what you wanted to do? Good. R plus 2, r plus 4. So what would my final answer be on this one? Sophia, go ahead. Just 5, because our r plus 4s cancel out, the r plus 2 cancels out, we only have 5 left. Okay, I would like you, I forgot my watch today, this is going to drive me crazy. Let's finish the last 3 on this page and then do the second page. I won't give you all 3 pages because we're still in the early stages of doing this. I don't want you to do a whole bunch wrong if you're not comfortable with it. So finish this page and then do the 8 on the second page.
There's only 7 because 3's crossed out.
Oh, okay. You're right. I forgot that I crossed out 3. If any of you want to try, no, don't try number 3. Number 3 involves difference of cubes. So if you were going to do number 3, you would need to look up somewhere, how do you factor difference of cubes, and figure it out. It's very doable, but there's a formula for it. It is a little tricky.